Jacco van Loon is from Keele University. He's an astrophysicist, actually the director of Keele Observatory at Keele University in the UK. Jacco, always great to have you on the program. Let's start with the Crew Dragon capsule. Because it's so new, is there any reason to question its dependability?
Yes, launching a rocket is always a tricky business. And so with any new spaceship, first you do tests, and first you do that without people. And a few months ago, we had the first flight with 2 astronauts on board. That was a test flight, and this is the first fully fledged delivery of a new crew of 4. Even now, before launch, there were several things that they had to check and double check. You mentioned leaking space station, but they also discovered that the hatch wasn't closing very well. So it is very, very, very dangerous, and everything has to be absolutely foolproof to go ahead with the launch. So it remains a very tricky business. But SpaceX have now more than a decade's experience with launching, and their Falcon 9 rocket is extremely reliable with very few failures. So that's why this was the rocket of choice to also launch the crew. But they're testing a new, much more powerful rocket, the Falcon Heavy, which would allow many more people at once to take into space, and also to launch parts of a space station, because you mentioned the space station as it is may not last very much longer. So is there a need to replace it? And yes, there is, not just for the science, which as a scientist myself, of course, I would wish. But Elon Musk is interested in space tourism and in venturing further away, all the way to Mars. First to the moon, of course, because NASA is, and with other agencies, are very keen to go back to the moon within a couple of years. But eventually to Mars, you need a very powerful rocket to do that, and you need a fairly large spaceship to get people there. Because the people there that going to Mars will stay also like 6 months in space, just like the crew in the International Space Station. So again, that's not a trivial thing to do.
Yeah, I thought one of the problems about going to Mars was that there's actually no way of coming back at the moment. And that's why Elon Musk a couple of years ago said, I don't mind dying on Mars as long as it's not on impact, which I thought was a very nice observation. What about the need? What about the need, Jacco, for even having the International Space Station? If humanity is going to establish a base on the moon, I mean, all the science projects can be done there, and the moon can then be used as a launching pad. Is the ISS even needed?
Yeah, well, it's still a good base to go to first, and then from there go to the moon. And probably there will be a space station orbiting the moon as well, just to make it all much more efficient in terms of the fuel. But also there's still a need for a laboratory in orbit around Earth to study the Earth itself, for instance, as well as doing the experiments on board. And space tourism. Elon Musk might just want to bring people to the space station so that they can be weightless and have a look at their home from orbit. So yes, there is still a need for a space station in fairly low Earth orbit, as well as a base on the moon, which has its own advantages, like you say.
What are the most important discoveries in science that couldn't have been understood without space travel? I mean, from your own field, if you like, or from another scientific field? Yeah,
so under weightless conditions, you can see how very, very small components behave, such as viruses and cells. And from that, you learn a lot about how cells respond, and this is very important for medicine, as well as to develop new ways of growing food, for instance. So it's quite fundamental research. So it doesn't often have immediate applications, but it's the kind of knowledge that you can only gain when you go to these extreme and very different conditions to do the experiments. As an astrophysicist, of course, I'm very interested in looking away from the Earth into space, and you can do that much better from above the atmosphere. You have access to types of radiation that doesn't penetrate the atmosphere. You can also be away from sources of light and other types of radiation, especially on the back of the moon, where it's not just dark if the sun is down, but also very quiet in terms of the radio noise that we have here with the communications and that.
Sure. Jacco, thank you so much indeed. You know, I mean, I think you realize by now we've spoken about 6 or 7 times, and I'm always super excited to hear your opinions. Jacco van Loon from Keele Observatory.